We got some problems from 4.2, 17, 22, 23. Any others we want to add to the list? Okay, we'll start with these. What's number 17? Yeah, show me real quick. Why does my camera feel like it's in a weird low spot today?
Oh no, I ran.
Okay, we've got hydrofluoric acid with potassium hydroxide. What's the pH? What's the pH? What's the volume? What's the pH? pH, volume. Oh, it's a titration problem for, okay, so we have 343.8 milliliters of 0.379 molarity hydrofluoric acid with 0.78 molarity potassium hydroxide. And we want to solve initial pH, pH at a particular point, midpoint, whole bunch of things. We're essentially doing a titration curve. I'll ask you for the specific volumes again in just a moment. But we're essentially saying, okay, what's the titration curve for this thing? I'm not even going to do this one looking at what the problem's asking for. Because whenever I do a titration curve, I kind of just approach it with what I think is important in titration curve. First off, the potassium doesn't really matter. That's a spectator ion. HF, we should have a Ka value associated with that. But I always start titration curves by drawing a titration curve.
I just had to ask him. He said he was going to send out the PDF of what it all means.
Okay.
What does it all mean? And then there are certain points that I always want to calculate on my titration curve. There's the volume to the equivalence point, volume to the midpoint, initial pH, midpoint pH, equivalence pH. Those are the standard points we usually calculate on a titration curve.
Yeah.
They're really handy to know, especially these volumes. They're really good to know to tell us if we're in the right spot or not. So I'm going to go ahead and do those calculations. I think they're going to line up with some of the calculations we do. And I've got a particular order I like to do it in that is sometimes different from what the problems do, because the problems usually walk us through like beginning to end. I don't find that the easiest way to do the calculations, even though it's the easiest way to make sense of the calculations. I kind of bounce around a bit. I always solve the equivalence point volume first.
I skipped it. I went straight to 4.
Because it's the easiest thing for me to do, and it's kind of the most useful. So I'm going to do my 343.8 times 0.379 divided by 0.78.
C, it's like use Euler's formula.
Probably like the EI pi.
Oops, sorry about that.
Or EI pi plus 1 equals 0.
Here we go. So we
1.
go ahead and plug those numbers in.
Or it's like the
3.8 times
it's like EI pi theta equals cosine theta plus I sine.
Ooh, I messed up.
That
No,
one.
I didn't.
That's that one.
Okay. I just got a number bigger than I was expecting because it's a bigger volume than I'm used to working with.
Yeah, okay.
So I get
Yeah,
167.05
No.
milliliters. So that volume
Yeah, I got through 1 and 2.
is 167.05 milliliters.
Ran into.
Now, does that make sense? My base is about twice as concentrated as my acid. So my volume of base is about half of my volume.
Because one of them is
That makes sense to me. Then I can go ahead and calculate my volume to the midpoint just by taking that 167, dividing by 2. And that's going to be 83.52. Right? These two things are related by a factor of 2. If I have this number, I cut it in half, that's that
far
number.
and gave up.
Easy so far.
I don't know.
Right,
the
then I go
LHAT.
ahead-
I was confused on what the LHAT squared operator is.
And I know what
Oh wait, we still this one. in class.
pKa, I know what the
Yeah,
Ka
but I didn't
is
get
from the
it.
equation
No,
sheet.
no, I think actually honestly.
Oh, if I can find it. 6.8 times 10 to the minus 4.
Oh, it's this.
Usually I like to go on the book to try to see what, but they don't have like a LHAT.
I can get my
that-
pKa?
This is what he was talking about. Okay, so.
Essentially,
Which is
you didn't factor out.
3.167.
Why is there what again?
And there's my
It
pH at the
depends.
midpoint.
This is that wave. That
If I
wave
could write it
function
first,
versus
so-
that wave
Gotcha.
function.
Well, he didn't factor out the
3.167.
He just kept them in.
Now, have I even looked at what the question is
Plugged in
asking yet?
L squared for
No.
the elsewhere that
But
we
these
looked
are
at
the points that are easy for me to calculate whenever I'm doing a titration problem.
Right.
Like, if you remember in class today,
Except you don't need
this
to write
is
down
my
the
think
science
step.
stuff, 'cause we're using
I always
wave
do
functions
this
as
stuff
data.
to frame
So all
how
of
I'm
this
going
you
to
can
do the
just
rest of the
disregard for
problems.
now.
Oh, okay.
And if I look at the problems,
We're just
I'm willing to
working
bet you this
in
answer is
the wave
like,
functions.
Okay.
this answer is 3 of them.
And that's what that is.
Mhm.
So it's just
I don't know which
working-
3. Does it answer 3 of the questions?
And then you just,
But
you really just factor,
what
you're just
is
doing
the
math
initial
when you're just
pH?
factoring out.
Oh, we haven't answered that one yet.
To solve for the wave function, which is
certain amount of titrate.
the difference.
We haven't done that one
At
yet.
the
from-
midpoint, we already did that.
Yep, got
What is the
that.
pH at the midpoint?
Got that.
I'm not sure if I explained
pH
that.
after adding a
or
certain
not,
amount.
but,
Don't
And
have
the
that.
volume of the equivalence, but we got that.
Got that.
And then
Essentially,
pH
we're
at the
just like
equivalence.
factoring
Okay,
out.
so
keeping it in
we've
wave
got
function
Oh,
notation.
is that
1,
okay?
2, 3,
And
4
then
things we
just
still need to
solve for-
calculate. So this had 7 parts to it.
wave
Okay, yeah,
function.
that makes sense.
We've done 3 of the 7 parts.
Wouldn't the best thing next is to
I think
do
it's
the
like
pH at the
zero.
equivalence?
Equivalence point or initial point, right? At this point, all the calculations, I find the initial point and the equivalence point are going to be easier than the, well, all of them are about the same calculation now. So now all of them are, the rest of the things we need to calculate are all stoichiometry, equilibrium, stoichiometry, equilibrium. Where the initial one is going to be the least amount of that because that's just equilibrium. So I'm going to go, oh, don't erase that yet, sorry.
Number 3.
I usually write that on the
Yeah,
other
I
side
have
of the
that, I
board,
got that
so,
one.
but I was doing work over there. So now all the parts are kind of equally difficult. Now we'll just go in order. So
Oh my gosh, I was the only one who got right on the test.
we'll do A and B. This was
I got
C. This was
That's
D.
the
This
only one
was
I got right on.
I
E.
got 3 and
That's right. So we did
6A,
C, D, and
right,
E already on this problem,
4B.
and so we have to
And
do
that's it.
A, B.
And, like 4B was a completely lucky guess, and 6 was.
No, this was A.
Oh, yeah, I didn't-
So at this point, the rest of the parts, any order, and we'll use this as reference for if our answers make sense or not.
Ballpark.
Yeah, yeah,
Okay.
no, it- I mean,
So
I didn't
for
do
part
good.
A,
Like,
it's just HF plus H2O goes to F minus plus H3O plus. We've got our point 379. We are just doing equilibrium.
I'll see tonight, right?
Yeah.
Right, we've done this so many times that I'm kind of over it. I mean, I will start just shortcutting this in the near future, where I skip the equal, I just jump to this now,
I
right?
did.
We've done weak acid and water so many times that we're just like, yeah, it's this, right? It always
I got
comes
to a
out to
point
this.
Where I found
So I'll
this
probably
part.
never write the equilibrium table for
So
an
when I go to
initial
try
point.
this,
Again, I'll just jump
I
to
get
that
0,
equation.
and I'm very confused.
And I can solve for x pretty easily, 6.8 times 10 to the minus 4
that's,
times
that's why it's signed
0.379
3
square root.
kind of
Did you
very-
change like I to natural
X is equal to 1.605 times 10 to the minus 2.
No, I
Take the
feel like
negative
if you
log.
multiply it, I think multiple.
1.794.
That might make things. a
Good
little
for that
easier.
one?
Because my e's, my imaginary canceled out because of that.
Okay.
I don't know if that's.
Now let's go
I
ahead
did not
and
do
do,
that. So
that was
what
A.
So for y11 and y20.
My colors are all getting mixed up. Don't pay attention to the colors.
Wait, is y the
Um,
individual wave function
Let's go ahead and look at part B.
for that L and M sub L? And then when you combine.
B gives us a
like,
specific volume. What does the specific,
that
what's,
wave function, that wave function, that's like the
48
total
milliliters of
overall wave
titrate.
function. right?
48 milliliters?
Yeah,
Like
titrate.
doing like y11 and y.
Now, if I look at this, 48 milliliters,
Like,
gonna be like there, right? Halfway between 0 and 80. So I'm gonna expect a number pretty close to 3.16. I'm gonna say 2.8. That's gonna be
wave
my
function
guess.
is this,
Halfway,
right?
2.1.
So, but these are wave functions themselves, right?
Mm-hmm.
So if we combine
Maybe
them,
2.7.
that's when it makes a new.
2.8, 2.7, right? And that's where I like to do this picture before I even start the problem, because it gives me an idea of what answer I'm going to expect.
These are orthogonal, right?
Now, to do this
So
one,
they would be, choose the integral.
we got our
times
two
that, it would
steps.
be 0,
Mm-hmm.
right? That's the whole point, but when you add them together? Or when would you add them? When would you add wave functions together? I don't understand.
We're gonna have to do.
Conceptually, I don't know what that
Okay.
is.
We're gonna have to do stoic and equilibrium, part 8.
For 8a, like why are you adding the two wave functions together? Like,
Real
does that
p
make-
functions. Remember the graphs I showed you at the end?
Mhm.
Oh.
That's why.
orbitals?
P orbitals.
So you add, when would you multiply them?
When you do separation of variables. Can
Okay.
you hand me my water bottle?
So when you add them, that is considered a new wave function? Okay.
And then, so you multiply into separation of variables, but like, what is that? I get the p thing, I get when you add them together makes a, but what does that mean when you multiply them?
I'll come back to that.
Okay,
in just a
okay, okay.
minute. Let me finish the.
Okay, yeah, no problem.
Okay. Sorry, I just inhaled something weird.
Take it down.
And I feel like that should be, oh. thank you.
Okay, so stoichiometry is going to be HF, just like we did in class today at the beginning, our warm-up. HF plus OH minus goes to F minus plus H2O.
I did
Calculator.
one for this one.
Calculating my
Just one through
millimoles,
four.
343.8 times 0.379.
I did it right. I really just took them as simple equation. I was like, yeah, it looks good now.
130 millimoles. Then I'm going to do 48 times 0.78, 37 millimoles. 130, really? Yeah, that's right. So minus 37, minus 37, 0 plus 37, 0, 37, negative plus 130.
Have you done this one? You know how class that he was like, oh, like, define L squared, you like
93.
this whole thing into the wave
Right, all in millimoles.
function. I just don't know if
Then I go ahead and I do my equilibrium. I've got weak acid and conjugate base present, so I just do this as HF plus H2O
yeah, like,
goes to
you, like,
F minus plus
Wait, that was the same thing you did last
H3O plus.
With 8 or not.
Making sure it's still on the screen, it's still on the
You
screen.
just he left it in with the wave function
93,
notation.
37, divided by volume total. I always put the divided by
left it
volume
instead of, like,
total in my
like,
equilibrium
that's
table,
equal to,
even
like,
though we know it cancels out,
This,
because
right?
equilibrium
Like,
tables always have to
like-
be in molarity.
Don't include this part, because if you just keep the individual wave functions as individual wave
Minus
functions,
X
you don't need to put, you don't
plus
need to
X,
input
0
theta
plus
and
X.
pi.
Gosh, and we're gonna get bored doing these pretty soon as well.
Wait.
Because again,
So, like,
these always end up being the
there's
same
two individual
thing.
wave functions, right?
Mhm.
Yeah.
Right, and
but
then
if
I
you
go
just
ahead and I
leave it
say-
as like that, you don't need to like.
KA, I'll just plug in what my
like
K
sign
is,
something.
is
You don't need to like actually output that.
6.8
So you
times
don't need to
10
worry
to the
when
minus
solving
4 is
When
equal
putting input this, you
to
don't need to worry about this stuff.
37 over
I
volume
don't know if that makes
total
any sense.
divided by 93 over
Like,
volume total
He just
times
left
H3O
that
plus.
in that notation. So part of the L squared, he only had this bit.
That actually ends up being easier math than our
And
last
he didn't worry
thing.
about theta.
No square
and
root,
phi's
just multiply,
because
divide.
You're not in
So I
that
do
notation.
6.8 times 10 to the minus 4 times 93
'Cause he
divided
just
by
left it. He just left it
37,
like that instead of inputting
and I get
all these.
H3O plus is equal to 7, 1 times 10 to the minus 3. pH is equal
You multiply
to
that by that,
2.7.
and then now that's what he's put here. That's what that is, right? L squared is
Why didn't you
this.
divide? Did you divide by the
Except
total
you don't
volume?
put any of
Yeah.
this stuff.
You
It
notice
says you're not in
volume
notation.
total, volume total,
I'm pretty
that
sure- I
bit's
don't
going to
know.
cancel
I
out
don't know.
again
Oh,
very
okay.
nicely.
So we have to write it in, but we technically, once we do the K expression,
Then-
it cancels out.
It cancels out. We always write it
Okay.
in because we need our equilibrium and molarity. Don't want to mess that up. But when we have this ratio, it always cancels out.
Sorry.
There are a couple places where it doesn't cancel out. The initial it doesn't cancel out. The equivalence point it doesn't cancel out. So that's why I always write it so I don't, because like if I get in the habit of not doing it, I end up leaving it in millimoles when I'm at the equivalence point and it's wrong. So that is how we
This is
do
L-
part
times L plus 1.
C, E. That was part
There's a way
B.
you could-
From this, can you all do part E and G?
Wait, so why doesn't it work at the
Oh, sorry, it's
equivalence point? Is that because there's different
Right,
amounts of
phases.
acid and base?
At the equivalence point, there is only conjugate base left. So
Oh,
you
right, okay,
don't
that's the point where it's
Yeah.
just OH left.
No, like I think
just conjugate
this
base,
is-
not OH, A
Oh,
minus,
right,
is
okay.
whatever our
Okay.
conjugate base is.
Well, it
In
should
this
just
case,
be
just
this.
F minus.
Okay.
So we
Like,
don't end up with a
that's
ratio,
right. It should just
so
be
we
this
don't
without
have the
square
total
root.
volume cancel.
So that's where, because we're running in this notation.
You end up with
Oh,
like,
because there's only one.
There's only one thing left.
Got it, got it.
so
Because
I'm gonna pause this.
sometimes you wanna
Questions
use-
before I let you all
you
work
wanna
on
use
that for a
betas
minute?
and phi's,
One
right?
question are relating.
But like in this case, we're
But
not
we were
worrying about
both
that. We're
wondering
just keeping it
how
as
we
an
can see
overall
what we
wave
got
function.
wrong on the multiple choice.
So
I
that's where
forgot
you-
to send that out. I
So
meant to
if you
send
were
that
to
out
do
right
that
after
with
class,
one
and then
function,
I
how would you
had
define
a meeting.
what
Okay, so
lowercase
it's just gonna
l
be
is?
sent out?
Yeah, I'm gonna send an email out. The email will come from Ikindi.
Yeah.
Oh,
And then- And then I'll send an email out to the class telling you to look for an email from
Sorry.
Ikindi for your multiple choice
Oh.
section. Thanks for reminding me of that. I
Okay.
totally
Is
forgot.
this
4.2
and
also
this are the
gives
same,
layers
you know,
that do
minus
like
the square root.
layer.
These are the
4.2
same
is due
things,
today.
just this is using phi and theta.
Can I get an
Whereas this
extension
is
for Sunday? Cause I'm gonna
This
be
is
out of town and I
simplifying
won't have
it.
servers to upload my.
Yeah.
Oh,
Is that
Shoot
right?
me an email or I'll
Wait,
forget.
is there one on Sunday too?
No. No. 5.1 got moved to next week and it'll be Friday next
I'm
week.
good,
sure?
I'm good, yeah.
I'm assuming so.
I'm gonna let you all.
You're also publishing the
But
video,
like
right?
maybe,
Yeah.
I don't know what number five
Okay,
is asking.
so I was gonna keep working on this one, but people want me to move on to 22, and then I have to help other students. Let's look at number 22 real quick. Can I look at 122? Is it a quick
I don't know.
one? Oh, buffer solutions. Okay, so I can do 22 on this. So, do you remember where on this curve is the buffer portion of the curve?
Yeah.
Cause like,
After the first
this is
one.
how I did it,
There, right?
and I just used like the simplified version.
I like your tones.
Thank you. I was class line, it's like, okay, this.
That's the
is
buffer
relaxing.
region. Which point in the buffer region would define like a good kind of measure of the buffer region?
I just like don't understand like.
Where's the middle of the buffer region? Middle of the buffer region is the midpoint. What's the pH of the midpoint? pKa. So you just find whichever one has the closest pKa to the desired pH.
I'm running out of brain.
It's just, that's, right, so here's the thing that I think is making this homework complicated, is we've done all of the math that's necessary, and we've done a lot of the conceptualization that's necessary. I just haven't used the word buffer yet.
Or like if you solved it like the hard
And
way.
so it's just like a language translation that you need to do. So that problem, if I just worded the problem so it's like, which conjugate system would have a pH closest to this,
Oh, wait, actually.
Super easy.
it was on it.
right? Which conjugate system would have a pH closest to this desired pH?
Never mind, it wasn't.
And it's just pKa closest to target pH. That's it.
And does it have like is there some sort of pattern with like, as more protons are removed, like as more H plus are removed, does it get more like
It's
like
different-
acidic or basic, or does it differ
More
per acid?
basic, so it's different Ka values for each proton being removed.
Right.
So if you look at the equation sheet,
They go
H3PO4 has 3 different ones that get smaller with each step.
Okay. Because it's harder to remove.
Yeah, after you've removed one, the next one is harder to
So it gets
remove.
as more protons are removed, gets more basic because it's harder to remove.
I would say it becomes a weaker and weaker acid.
Oh,
Which
I
means
see.
its pKa is a bigger and bigger value, which is it gets more basic. But I always try to think of Ka in terms of how hard is it to, how well does it behave like an acid.
L is like
Okay, so it's like,
overall, like the energy of, like,
yeah, so as it goes through, it's a
and
weaker,
so
weaker, like as more protons are removed,
degeneracy.
it's a weaker acid,
Yes,
meaning there's gonna be
Yes,
less
it
protons in
applies
solution.
to,
Yes.
Meaning it's gonna be more basic.
yes.
Got it.
The
Thank you
Yeah,
very much.
Z component
perfect,
of
okay.
angular
I'm gonna check on
momentum.
124
So if
real
you
quick.